Okay, lab number 2, organic molecules. Basically, if you look at the objectives, you will have to be able to recognize the model of an oxygen, water, carbon dioxide, methane, glucose, glycerol, a saturated fatty acid, an unsaturated fatty acid, triglyceride, a steroid or a cholesterol molecule, an amino acid, glycine and alanine, specifically 2 amino acids. Identify a dipeptide, a tripeptide, and the molecule of ATP, adenosine triphosphate. All right. Be able to recognize the following chemical reactions: dehydration synthesis and hydrolysis. Okay. Dehydration synthesis is how you put complex molecules together, and hydrolysis is how you break them apart. Recognize the functional groups on organic molecules. Be able to answer the study guide questions at the end of the exercise. Don't worry about that so much as being able to identify these molecules and what I just said. So number 5, and number 2, you're not going to be building glucose or disaccharide or a dipeptide or an amino acid. You're just going to be able to recognize the following. Okay, we'll go through a couple preliminaries. One of the first things, and when we get over there, you'll see it's also listed in your book on page 11. The atoms themselves. If you see a black marble, it's carbon. If you see a white marble, it's hydrogen. If you see a red, it's oxygen. Blue is nitrogen, and purple is phosphorus. And you'll see that when we get to the 3D models over there. A single flexible gray stick or rod is a single covalent bond. And if you see 2, it is a double covalent bond. Okay. We call them carbon bonds, single, double, and triple carbon bonds. You would think that a triple carbon bond would be the strongest. It's not so. A single carbon bond is preferred. A double carbon bond is used sometimes when you have to take up for the account of missing carbons. And a triple bond is really unstable. Imagine juggling pizzas. If you're carrying 1 pizza, that's more stable. You're carrying 2 pizzas, not as stable. Carrying 3 pizzas, you know what's going to happen. All right. We're going to be able to identify some non-organic molecules: water, methane, oxygen molecule, and carbon dioxide. Okay, Roman numeral 2. All right. And so what I'm going to do is I'm going to talk a little bit about the 3 different groups. Those molecules over there are basically divided into carbohydrates, your fats, and then your peptides or proteins, which are made up of amino acids. And we'll talk about those. So first, we want to be able to identify some functional groups. If you're taking a look at the bottom of page 14, our first functional group is called an alcohol group. Okay, the alcohol group also goes by the name hydroxyl. Make sure that you understand both of those. Okay, it's an oxygen and a hydrogen. Okay, hydroxide, OH, also turns solutions into a base or make them more alkaline based on the concentration of hydroxide. So this is also known as a hydroxide molecule, OH. Okay, but as an alcohol group, if you have a methyl group and you add an alcohol group, OH, you now have just made methanol. Or if you have an ethyl group and you attach an alcohol group, now you have not methanol, but ethanol. And ethanol is something that goes into your gas as it is right now. So OH is the guy you're looking for. That'll be a red molecule attached to a white molecule, and you'll see that here shortly. All right, second functional group is the amine group. That's how it should be written, but your book says amino. I guess both are okay, but the amine group is made up of a single nitrogen bonded to two hydrogens. Okay, so you remember nitrogen is blue, hydrogen's white, a blue marble with two white ones. All right, so your amine group. 3, your acid group. Another name for an acid group is carboxyl group. Carboxyl, C-O-O-H. High school, I memorized this as the COO group, okay? COO. 1 carbon, 2 oxygens, 1 hydrogen. And by the way, if you take an amine group, add it to an acid group, you make a amino acid. Okay? So let me zoom in. Okay. So I'll try to mark where I can draw. All right, let me erase this and do our last group, number 4. Maybe I should write larger too. And I believe our last group is a methyl. And the methyl group is simply a single carbon with 3 hydrogens attached to it, and I'll just put X there. X is attached to that, and I'll tell you a little bit about methyl group when we get to the point where we are talking about the methyl group. All right? All right, so those are your functional groups. I don't know how to pause this, so I'll keep talking. I want to put some tape down so I know where the tripod legs are at. One there, one here, and one there. I'll take you guys for a ride, and I want to show you. This is what I do in class. I do everything in 2D, 2 dimensions, and then I come over here to our table, and what you see here is all these molecules. You're going to need to know their name when they put them out in front of you, and you will be, and this will be very helpful for you. So okay, that's pretty good. Move these guys a little bit over right here. All right, so here are your marbles. All of these organic compounds are organic because they all contain carbon. They also have oxygen very often. They also have hydrogen and nitrogen, and didn't pull out a purple one, but I will show you the purple. The purple are phosphates, or phosphorus rather, not phosphates, because phosphate is something else. But phosphorus is in purple. And here are your functional groups, okay? Starting off with hydroxide group, okay? Let me see how that's looking. Yeah, that's good. Hydroxide group, an oxygen and a hydrogen, okay? Next is the amine group, or the amino group, NH2, one nitrogen, two hydrogens. And here they are in the structural, the nitrogen, okay, and two hydrogens. So your amine group. Next is your acid group, or carboxyl group, okay, carboxyl, or your acid group. COOH, COO. Okay, so amino acid. There's something here that's in the middle that we'll see. And then finally, you have your methyl group. One carbon, three hydrogens. That's your methyl group. Okay, so if they throw this down right here without a tag, you got to leave it like that. Can't be moving it around. Well, I'm talking like you're going to be here. Someone's going to take a picture like this, maybe they move it around, maybe they do something like that, and they say, identify this molecule. That is a methyl group, okay? Identify this molecule, okay? Carbon, hydrogen, two oxygens. That is your carboxyl or your acid group, okay? Could throw the amine group down, okay? So that's what's going to happen. They're going to take a picture more than likely, and you're going to have to be able to see that. All right, let's take a look at the inorganic molecules that you'll have to know. The rest of these are organic. These are inorganic. First one is two reds. So that is your oxygen, okay? O2. CO2, everyone knows that that's carbon dioxide. So they'll throw that down right there, and they'll say identify this molecule, CO2. Okay, H2O. H2, two hydrogens, one oxygen, obviously water. Okay, so they'll throw this down and show you like that. And then, if you've had too many frijoles, this might come out of you. It's methane. One carbon, four hydrogens. Methane. All right. Now, they may not just put these individual molecules down. What they might do is bring something out like this and say right here, between my two fingers, maybe there's some tape right there, but they might say, what functional group is this? An OH. This is a alcohol group. Okay? Alcohol group. Okay? Somebody, they may pull a molecule like this and say right here, okay, this nitrogen and two hydrogens, what group is this? And of course that would be amine group. One single nitrogen, two hydrogens. They might go over this end right here and carbon, oxygen, oxygen, hydrogen, the acid group. Okay, so this would be the acid group right here. And so you just need to be able to identify those. Okay, let me put some tape down over here so that when I come back over here, Okay, we are going back to the board to talk about carbohydrates. I'll put my camera on its tape markers. Okay, and there are my, next, try writing in blue to see if that contrasts allows that to come out better. Trying to find my marker, my black one. Yep, that's good. All right. I'm going to abbreviate carbohydrates for carbs. Yep, that's in there, Bert. All right, so what are carbs? Carbs are sugars. And these sugars, okay, have a fancy name other than the word sugar. They call them saccharides. So all three of those words basically mean the same thing. Trying to get it focused better here. All right. So sugars, saccharides, carbs, all mean the same thing. Okay, carbs, sugars, saccharides. Now, sugars or carbs can be simple or they can be complex. Okay, they can be simple or complex. For instance, a simple sugar is known as a monosaccharide. Okay, a simple sugar is known as a monosaccharide. Okay. Perhaps the most complex sugar is simply known as a polysaccharide. So some examples of monosaccharides are glucose, fructose, and one more you're going to need to know is ribose. Okay? Okay, let's zoom in a little bit. Okay, so carbs, sugars, also known scientifically as saccharides. Simple sugars are monosaccharides, such as glucose, fructose, and ribose. You can find those in your book, your textbook. The most complex is a polysaccharide. Well, is there anything in between a simple sugar and a complex sugar? Absolutely. You can have a disaccharide. And what does the word di mean? Exactly, it means two. Okay? And perhaps the most famous, and I'm going to erase complex here so I have some room, is when you take two monosaccharides, all right, and join them together to make a disaccharide. For instance, glucose, and add it to fructose, okay, and that makes something we call sucrose. And sucrose is a disaccharide. Okay? Sucrose is a disaccharide made up of glucose and fructose. Well, if you have monosaccharide and you have disaccharide, can you have a trisaccharide? And of course you can. Okay, of course you can. Okay. Carbs, sugars, saccharide, simple sugars, complex sugars, monosaccharides, disaccharides, and trisaccharides. Try to keep these consistent so you can see that. Okay, mono, di, and tri. All of these words are very similar, and you will need to know all of those. Okay? Let me try and show you a little bit of structure. Turns out that glucose is what we call a 6-carbon ring. Okay? The key to understanding organic chemistry is to be able to pick out the identifying feature that is going to be radically different amongst all the different molecules. If you guys were here, I'd be talking about somebody in class, and I might point to somebody and say, here's an individual. How do you recognize a certain individual? Do you recognize them by their toes, their feet, their hands, their waist, their knuckles, their elbows? Yeah, all those molecules that are models over there have toes, feet, arms, legs. But you need to be able to find the face, because that is how you identify organic molecules. You simply look at the face. If you have the face, that is what is discernible amongst all of the individuals that you might find in a classroom. Well, those models over there can be very, very similar, okay? But trust me, between a carbohydrate, between a lipid or a fat, and between proteins, which are made up of amino acids, all of those have a different face. And if you can just recognize the face, it's very easy to tell all those models apart. Anyone they put in front of the camera, you'll be able to identify it just like that, if you understand the face. Now, I told you that that our glucose molecule is a 6-carbon ring. But if we count 1, 2, 3, 4, 5, there's 5 carbons, and right here is an oxygen. All right, so there's 1 oxygen, but there are, count them, 6 sides to this ring, and we call it a 6-carbon ring. All right, so I could write this. Glucose is a 6-carbon ring. Okay, now, granted, there are other things coming off of here, okay, and we're not drawing those because this 6-carbon ring is our face. That's what we want to notice about this. So, staying right there, I am going to grab my glucose. These molecules, these models have become shorter. Okay, let me eyeball where I need to hold this baby. Okay. So here's the face. I can stick my hand right here if my wrist was small enough. All right, I could stick my wrist right through here, and I could wear that as jewelry, which I don't know. That's what happens to old people, I think. Some of you might have grandmas. They've quit wearing gold and silver and platinum, And they've changed all that into like plastic jewelry that costs like $3 on eBay or anything like that. They're just like necklaces, everything. But so this is my glucose, okay, ring right here. So I'd have people grab this and put their finger right in, or fingers right in there for that 6-carbon ring. So if I hold it to the side right here, here we go. 1, 2, 3, 1, 2, 3, 4, 5, 4, 5. Boom, oxygen guy right there. And see all this stuff coming off all these hydrogens, these OH groups? Don't worry about that. A 6-carbon ring. A 6-carbon ring is glucose. 6-carbon ring is glucose. Okay? Now, we could just put this right here, and I could point and say, identify this molecule. I can flip it around for you. I don't know if Eric's going to do that. He'll probably just stick it in one place like that and say, identify this molecule. Okay? Now, you're going to have multiple choice. You look at this and you go, hey, that's a glucose. But the word glucose is not one of the multiple choices. Well, you're thinking, what's up with that? It's a glucose molecule. I can see the face, the 6-carbon ring with one lousy oxygen sitting there. But don't forget, this is also a what? A carbohydrate. It is a sugar or a saccharide. Specifically, glucose is a simple sugar, is it not? And it's also referred to as a monosaccharide. Specifically, a simple sugar known as a monosaccharide, which has the name glucose. So if you follow this reasoning here, these are all the possibilities. You see this pop up on the screen. What is it? It's a carb. It's a sugar. It's a simple sugar known as a monosaccharide, which is called glucose. You need to know all those names. Okay? Now you might be saying, that's hard. Well, you've done hard things before. But trust me, if you were left to do this on your own, you wouldn't be able to identify that. I've given you the key to figure out all these, and we're going to go through every one of those molecules, and you're going to see exactly how they exist. Okay? So, glucose. All right? Now we're building our sugar. Back over to the board. I should put everything over here. Oh well, I'll remember next time. So I'll put glucose over there. All right. Let me erase my monosaccharide. Let me put glucose right here.